Swayam Prabha. Digital India. Educated India.
Welcome to the second lecture of the course Geoenvironmental Engineering. Today we are going to look at sources and impact of contamination. But let's just quickly go through what we did last time. So last time was an introductory lecture. We defined what is geoenvironmental engineering, and we said it's a confluence of geotechnical engineering and environmental engineering dealing with contamination on the ground surface and beneath the ground surface. And we talked about how the lectures for the next 42 hours will be distributed, and we said a bulk of the lectures will be on landfill design and design of slurry ponds, and the remaining would be on contaminated sites. We also looked at how the evaluation will be done and what are the textbooks which we will follow. So taking off from where we ended last time, today let us look at sources and impact of contamination. So when I talk of sources of and impact of contamination, do remember that I am talking of contamination on the ground and subsurface contamination. I am not discussing here contamination of water, contamination of air, which is what is traditionally done by the environmental engineers. So we look at what happens to contamination on the ground and contamination in the subsurface environment. So what are the sources of contamination? Briefly, we had discussed this last time, and we are saying the sources of contamination are the solids and the liquids which are either stored or transported on the ground or beneath the ground. So as long as a solid material or a liquid material is stored above the ground, it's a totally different thing. Why? When you store something in a bin above the ground, you structurally design the slab to take the load of the waste and to also be waterproof. That means if a bin is above the ground and it starts to leak, then you can actually see drops and droplets of the leachate or the waste water coming out. But the moment you bury it under the ground, what happens? You can't go beneath the base to see what's happening. So that is the major difference. When solids and liquids are stored or transported on the ground or beneath the ground, they can become a source of contamination. Primarily because we should be able to detect leakage. So such storage may take place in dumps like garbage dumps, in impoundments like slurry ponds, even drains which are carrying wastewater, or channels which are carrying wastewater, or pipelines which are carrying wastewater like sewage pipeline, or tanks, underground petrol tanks, or drums which have been buried under the ground with some waste. All these can leak and cause subsurface contamination. The contamination can come from municipal sources. That means they can originate from an urban environment. They can come from industrial areas. They can also come from the agricultural sources, mining areas, thermal power plants, and others. So we have not covered everything, but these are the major sources from which we do know that ground contamination and subsurface contamination occurs. So last time, if you recall, we were saying that if we have waste, we would like to utilize as much of the waste as possible. And if I have municipal solid waste, I can recycle the metals, I can recycle the glass, I can do composting and get compost. I can also, if there is energy in the waste in the form of plastics or paper or rags of cloth, we can burn it to recover some energy, of course with proper environmental protection such that none of the harmful gases go out from the incinerator, but still we would have some waste to be disposed on the ground. And this waste then has to be put in a manner in which it does not contaminate the environment. A lot of research is being done that if you have residual waste in the form of ash, for example, you have burnt everything and ash is remaining, but we find that the ash has got some contaminants, how do we entrap it in a glassy matrix? What is glass? What is the main? SiO2. What is sand? SiO2. What is ash? SiO2. So if I can transform the ash into a glassy matrix, then I can entrap the contaminants in that. Till we do that, we have to still manage the waste which is coming on the ground. So you will recall this diagram which we discussed last time, and just to make one more point, I said last time that cities are next to rivers or some water bodies, and that if I dispose some waste or if I have a pond with some not so nice liquid stored in it, then it can contaminate the groundwater. And I also made a statement that the groundwater flows towards the river. Is that a correct statement? Does the groundwater always flow towards the river? Well, let's look at the ground surface first. Within a watershed or within the catchment of the river, all the ground surface tends to go towards the river because the river is the lowest point topographically. So the ground slope is always going towards a river or towards a lake, which is a natural low-lying area. What about groundwater? Very often the groundwater will also follow the profile of the ground surface. So that means the groundwater goes to the river most of the time. But there is one issue that you should be aware of, that if the river level rises, so a river can be in flood. So if the river level rises, what happens? So during the lean period, that means during the summer months, the water level may fall here and the water table would begin to get lowered as it discharges into the river. During the floods, a recharge takes place. That means the water level in the river becomes higher than the groundwater table outside. So in such cases, the water can flow in this direction as well. So do remember that flow takes place in both directions, but for bulk of the time, the groundwater table follows the surface of the land and flows into the river. So this, I think, is depicted here, where the river has risen during the floods, and during those periods the groundwater is flowing towards the land and the groundwater table is being recharged by the river. But most of the time it is flowing into the river. So what we have said now is that subsurface contamination or ground contamination is not only on account of the solid waste or the liquid waste in a pond or a solid waste, but if you have buried some drums, if there are some pipelines, if there are some underground storage tanks, or any facilities which are underground, they can cause groundwater contamination because most of them leak. And the problem is we are not able to detect the leakage or monitor it. We are not able to detect the leakage or monitor it. So let's look at municipal sources. What are the municipal sources which will contribute to ground contamination or subsurface contamination? We've already talked about garbage dumps or municipal solid waste dumps or unlined sanitary landfills. We will better define this term later, but sanitary landfills are waste dumps in which the waste is covered with soil on a daily basis. So these are the old concept that you put the waste on the ground and cover it with soil, and it gives a good appearance. It keeps the pests and rodents away. It reduces the smell. But if the landfill is not having a liner at the bottom or impermeable strata at the bottom, it can still cause contamination. Sometimes municipal wastewater or sewage is applied to the land. This also can cause subsurface contamination, or the sewage sludge coming out of the sewage treatment plant that is also spread on the ground. So these are also sources of subsurface contamination. Septic tanks, where the sewerage system has not been developed, we are cleaning them every once so often, but they are also a source, and leaking sewer lines. So really, if I was to go beneath a city, if I could be a burrowing animal, so, and then I travel underneath the surface, ground surface of the city, so in drops of liquid would be coming down from the ground. Drops of the liquid would be coming down from the ground. If there's groundwater table, it will contaminate it. If there's no groundwater table or the groundwater table is deep below, that liquid gets held by the soil. So in any case, the soil gets contaminated or the groundwater gets contaminated. So this is a nice photograph of a municipal waste dump in one of the Indian cities. You can see a lot of black stuff here, right? This is because occasionally there is a fire, and you can see some black liquid here. This is what we call leachate, which is just ponding up, and the height of this dump is about 40 meters. So anybody who knows the height of Qutub Minar? So as I said, that 40 meters means 3/4 the height of Qutub Minar, and this dump keeps on rising because we don't have another place to put the waste, because in urban environment the space is very restricted. So this is causing subsurface contamination. Firstly, it is causing contamination of this ground, then this leachate is going below, so it is doing subsurface contamination. So this is one city, this is another city. Looks the same, very much similar. Similar height, this is about 20 meters. That you can see is a human being. So how many meters is this guy? So you can just sort of multiply him as many number of times as you want to get the height of the dump. And that is the kind of leachate which is flowing out here. It is flowing, is very close to a water body. You can see this water body. And therefore it is contaminating both the water body and the soil beneath it. So I'll come to industrial sources later, but what we are saying is that as long as I start to typically what happens, dumping of the waste starts in a low-lying area. Why? Because it's low-lying, one feels that if I dump some waste in it, it will come to the ground level, but it will not be an eyesore. Then what happens, once waste starts to accumulate here and waste keeps on coming in from the city, unless you have alternate facilities, then this waste starts to gradually rise. So this may be the history of a waste dump. And if I have rain, since it was a low-lying area, the water will pond up at the bottom, right? You'll have leachate. But there are many other things associated with the dump. It will give you bad odor. Those of you who are aware that what happened recently in Bombay, the Deonar dump caught fire. So there was a lot of smoke that in that region the schools had to be shut for 10 days because a lot of smoke was emanating from the dump. So the dump may cause lots of problems. It can be, leachate is one of them, bad smell is another. Smoke from smoldering fires is another. They do produce greenhouse gases. We'll look at these, but this is the source of contamination. If you are looking at industrial sources, so industries are also producing they are also producing liquid waste, they are producing gaseous waste, and they are producing solid waste. And as I have already told you, the more I restrain the liquid waste and the gaseous waste, the more both of it comes to the ground along with the solid waste which is coming out, because gaseous waste will catch the ash and bring it to the ground, liquid waste will go to an effluent treatment plant and it will give the sludge, all of them becomes solid waste. Now, typically in urban environments, you earmark an industrial area so that you are able to promote the industry. So in a city, you will have an industrial area. So that means a lot of industry is concentrated in that area. So one of the ways of managing the waste of the industrial area is to set up common facilities. Common effluent treatment plant. That means from all the industries, let the effluent come to a common treatment plant and it can be treated there. The problem is the complexity. If in an industrial area, you have one type of industry, say textile industry, or you have oil-based industry, then you can treat the effluents together. But if you have heterogeneous industries, somebody is making pesticides, somebody is doing dyeing, color, somebody is doing chrome plating, then you have waste which is of very different nature. And most of the effluent treatment plants, common effluent treatment plants, have not worked well in India in industrial areas which have got different types of industries. So just like you try and manage the effluent in a common facility, industrial areas also tend to manage their waste now in a common facility called a TSDF. And it's basically a storage and disposal facility. Storage and disposal facility, or a central storage and disposal facility. The TSDF stands for, so if I send it to a common facility, in India we call these treatment, storage and disposal facility. When you will go through the regulations, you will see that the ministry and the Central Pollution Control Board wants that for a cluster of industries have a TSDF where you can treat the hazardous waste if it is very hazardous, you can store it temporarily, and finally you can dispose it. You store it, if you can find a reuse for it, you can send the waste to them. So what we find here is industrial solid waste generated by the manufacturing processes comes to TSDF. The ETP sludge, effluent treatment plant sludge, which is different from the solid waste generated by the manufacturing process, that also comes to the disposal site. Both of these are solid wastes which can affect the subsurface environment. Even more potent are liquid wastes. As long as they are stored above the ground, and now there is a big move by all pollution control boards asking industries to store all effluents above the ground. But most of the old places you'll go, you'll find tanks, you'll find ponds, you will find underground storage tanks. So liquid wastewater or liquid processing water, even cooling water, when it is stored in ponds, impoundments and underground tanks, this can slowly leach into the ground. And of course, leaking pipelines and tanks. So the solid waste, the liquid waste stored, and the transporting elements which are used, all three can contribute to subsurface pollution. Here is a photograph of a sludge being disposed of by an industry in an excavated area. The same industry is also keeping its wastewater in a pond. Now, there are specifications as to how do you line this wastewater pond so that the leachate does not go into the ground. But if you don't follow them very rigorously, some leakage or the other will occur. And you can see the quality of brick lining that we have here. It may be underlain by clay or other impermeable elements, but the quality has to be done very well. If I look at this, this is an industrial area and this is temporary storage of the processing fluid beneath the ground. And when this happens, you may have a situation like this. This is a well, a groundwater well, and it's got black water in it because the water has leached from a wastewater pond or from a sludge and reached this well. So municipal solid waste, you saw the kind of leachate, look black. So the learning is that we have a lot of black liquid around, right? Occasionally it may be light brown, occasionally it may be dark brown, and occasionally it may be black. But you get a lot of color, and you get, and you know, you are drinking off your tube well. You have even a very light tea colored liquid coming, the tube well will be closed. You won't drink because you know that it's got a contaminant in it. Even if it has got a harmless color. In one of the industries we went, it was just like a sugar, you know. Caramelized sugar is brown. I don't know whether you understand the word caramelized sugar, brown sugar. So actually the color was coming from caramelized sugar. So if you drank it, nothing would happen to you. But it's brown, water is brown. I can't serve it to my guests. I can't drink it any which way whatsoever. The other source, which is a diffuse source, please understand, is agriculture. Diffuse means because we apply fertilizers, soil amendments, pesticides to a large area. So as long as these are within limits, that means there is no excess fertilizer, there are no excess soil amendments, and there are no excess pesticides. They are supposed to remain on the crops and within the boundary. But unfortunately, we are not able to regulate this, that this is within the limits and this is exceeding limits. So when the rain comes, these will all go off into the nearest drain. And once they are in the drain, which is always full of water, they will reach the subsurface. So these are not point sources, these are surface sources, and only when they are in excess do they get washed to the nearest drain, and they are getting, we are getting the contamination. In many agricultural practices, you have animal husbandry, for example, milk producing units, meat producing units. So there also the processing as well as the dead animals as well as the droppings of the animals, all of them have to be treated very carefully, otherwise they can become a source of contamination. So we don't see it, but you know, if you go to a poultry farm and you have X 100 or X thousand hens. Anything which is a concentrated animal activity has a trade-off onto the environment beyond it. Where do you dispose the carcasses? How do you incinerate it? Do you bury them, the animals which got sick? So these are also reaching the ground. And finally, food processing units, which you can just take as equal to any industrial unit. Food processing units are same thing as a chemical processing or a biochemical processing unit. So they also produce the same thing which we had discussed earlier. The next source which is important is the mining source. How many of you are familiar with mines, or how many of you have visited a mine? Okay, which mine? Was it an open mine or a closed, a deep below? Open. So what kind of a size did it have? If I was to make you sit on an aeroplane and ask you to look down, so they have excavated something from the ground. So what is the size of the excavation in plan? 2 kilometers in length, and how much in width? Is that big a pit? And how deep is it? Approximately. More than 200 meters or 100 meters. Okay, so here is somebody who has visited in Dhanbad a coal mine, which if you sit on an aeroplane, you will find that its planned size is 1 kilometer into 2 kilometers, and at the deepest point it may be more than 100 meters deep. So what are we doing there? We are digging out first the earth at the top, and then you come to a coal seam and we dig out the coal. Is that what's happening? Right? And we are using this coal and we are sending it to thermal power plant. For example, maybe it's coming to our Badarpur thermal power plant in Delhi. So from Dhanbad, you get coal, you put it in a train, you send it to Delhi. At Badarpur power station, we burn the coal, and what happens? Ash is generated. We all get electricity. Ash is generated. Ash does not go back to Dhanbad to fill up that cavity that we have created, and the ash accumulates. So there are two issues here. One is what are we doing at the mining site, and the second is what are we doing at the thermal power plant site. So the mining site can always say that I am sending my coal to Delhi, I am not producing any waste. But does the process of excavation cause a problem in your mind? Do you think if I make a cavity which is say 1 kilometer by 1 kilometer and 100 meters deep, what is your immediate concern? Please remember that to reach the coal, I may have first dug out the soil and the rock for about 50 meters. Is that correct? Or was the coal seam more at the surface? Was the coal deep below or at the surface? Right. So I may have removed soil which was 50 to 100 meters. So what do you think are the environmental issues here? All mines may not be open cast mines. Some mines you can just go deep below and work underground. And the ore, you may not want to remove the overburden. So you have to actually do the costing here. So here's Mother Earth, ground surface. Here it has a resource that we want to remove. There are two ways of doing it. One is you do this, and the other is you do this. So when this is limited in depth, then you'll do an open cast mine. And when it's very high in depth, in Hatti gold mines, for example, you're 2 kilometers inside. You're not going to do a open cast mine. So we are discussing an open cast mine, and what do you think it does when we have an operation like this? This is just a conceptual diagram. Please don't think that this is an actual depiction of a mine. So first problem is I remove all this overburden. Where does it go? I put it on the side somewhere. Maybe it comes here. So this is called overburden. Some of it, as we dig along, we'll put place back in the same area. But we'll have a large cavity. So what is happening? One is we are removing overburden. Okay. Is there anything which is going to happen when you make a deep excavation like this? Unstable slopes, so we will make them flatter. A slope stability problem, he says when you are going to go 100 meters below, you want to excavate it at 1:1. Firstly, it will be rock, so you can do steep slopes, but if you can't, we can make them flatter. What is the one major environmental change, other than the fact that you have used 2 kilometers by 1 kilometer area and used it for bringing out coal, which we need? What is the one major change that you have caused?
Proximity of groundwater.
What do you mean by proximity of groundwater? So if the groundwater was at 20 meter depth, what did you do when you did a 100 meter excavation? You lowered the groundwater. If you lower the groundwater, what will happen all around? Suppose the groundwater was here. We will not go into the technology of how you lowered it, but I have lowered the groundwater. When I lower the groundwater, what will happen? Maybe this is the drawdown curve. I'll be pumping out the water all the time. So the region will witness a depletion in the groundwater. So all the farmers, I'm not talking of the 1 kilometer by 2 kilometer area. Now I'm talking about the 10 kilometers on either side of that great cavity that you've got. But the water will go into that cavity. So the land gets affected because the groundwater goes down. So ideally, what should we be doing? Ideally, we should be maintaining the groundwater. And maybe we should be, from an environmental perspective, remove the water and put back the water, so that this part of the water is not affected. That's what happens when the metro does excavation in Delhi. It removes the water from the excavated portion, but beyond 50 meters, it cannot deplete the groundwater. So there are extraction wells, and then there are injection wells at 50 meters. Why? Because if you deplete the groundwater, the buildings may begin to settle. So basically, we need to keep the groundwater at its original position, which is a fairly complex technological activity. So there are two things which are happening. An overburden is being placed and groundwater is being lowered. So mine overburden is one problem. Huge mounds of mine overburden are placed, mountains. But this is mountains of crushed and excavated material. So if you have a mountain of crushed and excavated material, dust will fly. When the rain will come, the water will carry away the suspended particles and go and deposit it in a nearby lake or a nearby river, wherever the water is going. So these overburden mounds have a problem. And then, as I said, in the case of a coal mine, the coal is virtually in a very pure form, right? But if you have a metal mine, let me say I'm taking out zinc. So the ore may have only 5% zinc. 95% will be the rock in which the zinc is. So you'll crush the rock. And so we will get mine tailings, which is in the form of a fine powder. And these are large quantity slurry wastes which are deposited on the top of the ground. And then, of course, we also have mine processing liquid waste. If I'm doing the extraction of zinc from the ore, it's just not a physical separation. I take the rock and I crush it and crush it and crush it and crush it and crush it. Now it's fine, it's crushed. What is the specific gravity of zinc and what is the specific gravity of rock? Specific gravity of soil. Specific gravity of rock. Same. We are talking of the specific gravity of the solid matrix. 2.65, 2.7, 2.8. Specific gravity of metals, 5, 6, 7. So I have crushed and crushed, and I have two sets of materials, one is heavier, one is lighter. I'm not saying just by crushing you can separate them. No, I can't separate the very fine particles. The very fine particle has got 80% zinc and 20% rock still sticking to it. Then you do some other process, a chemical process, a separation process. So that will give you mine processing liquid waste. So you will get the crushed rock as tailings, and you'll get mine processing liquid waste. And when the tailings will come out, will they have any zinc in it? Let's say the original ore had 5% zinc. When the crushed tailings will come out, will they have 0% zinc? It may be 0.1%, it may be 0.2%, because you can't remove everything. And if it has lead, then maybe the tailings are also hazardous, classified as hazardous. So tailings will have some residual metal in them. So let's have a look here. What mining does to an area. This is not a below ground mine. This is an above ground mine. This is a shot from a magazine called The Sanctuary. And this is an iron ore mine in the south of India. And these are the original, these are the hills. And all of them have the ore. And this is what we are doing. These are the processing units. And what is happening to the tailings? This is a 100-meter high dam, okay, like a water reservoir. Can you see this? And behind that, you think this is water? This is all the crushed rock. Part of the crushed rock is overburden, which is somewhere else, which I don't have a photograph of. But the crushed rock which went through the processing unit is in the form of tailings. This is like powder, sand, silty sand, sandy silt. And this is 100 meters high, and this distance is about 4 kilometers, 3 to 4 kilometers, like a water reservoir. So this can impact the environment, and this can impact the environment, the subsurface environment. As geotechnical and geoenvironmental engineers, we want to always bring back the ground to its original condition. I can't, of course, bring back all the ore here, but I would like that this looks like this eventually. Isn't that what I want to do? And that is the whole topic of rehabilitation of mines, which we are not going to get into. But some of the problems associated with this, because this is all a geotechnical design, the design of the dam, how do you raise the dam, that we will be handling in this course. This is another tailings dam. This is about 40 meters high, and that is the lead zinc tailings behind the dam. Then another source of a lot of solid waste is our thermal power plants. They produce a lot of ash, I told you, coal ash. So somewhere here is the thermal power plant. It's not in the photograph here, but this is the ash pond created. Looks very similar to the tailings which we saw here, na? Yeah. And slurry pipelines bring in the ash. They're coming out here. This is the embankment, and this is the water which is then being decanted. So we have about 80 to 100 such ponds in the country, with several million tons of ash accumulated behind them. And then you can have other sources of ground contamination, spills. You have a tanker which is carrying something, it has an accident, it spills something. Stockpiles, you're temporarily stockpiling some, including coal, you want to stockpile something, you don't have a covered shed. So it's being stockpiled in the open, and it's down. Lagoons, like ponds where we are storing material. In the past, the industry used to inject their wastewater into the ground using injection wells. Nobody thought about it because this will pollute the groundwater eventually. And now they are no longer allowed, but this is a reality of the past, that we didn't have a river nearby, we didn't have a drainage channel, we used to inject the wells into the ground and say, oh, we are injecting it into impervious strata, it won't spread from that area. Buried drums, indiscriminate disposal. You can see here chromium sludge indiscriminately just put on the surface, and that's the color of the water. A very nice iced tea color, maybe lemon tea, whatever you'd like to enjoy, and surface discharges. So these problems are there, they're not very visible. Air pollution is omnipresent, we can see it all the time, we can smell it all the time. Water pollution, if you go to the river Yamuna, it becomes very evident. You look at the Najafgarh drain, all these water pollution problems become evident. Ground contamination and subsurface contamination is not visible. And all these things which go into the ground don't travel at a very fast rate. So they don't spread very fast. So they are there, they are moving gradually. In some locations they will spread rapidly, in others they don't. So what are the pathways? These are the sources. How does the contaminant go from the source to you? How does the contaminant bother you? I've got a mound there of garbage lying in Okhla. मैं IIT में हूँ, why should it bother me? So you can have various routes by which these contaminants can travel. You can have the gaseous route. The predominant route is the leachate and the surface water. Please do remember. But I'm just putting you can have the gaseous route. In many of the municipal solid waste dumps, huge amounts of methane and carbon dioxide are being produced. And these, if the dumps are below the ground, low-lying area, then the methane can even travel into the soil and pollute the soil and affect the crops nearby. In any case, the methane is coming out and it's a greenhouse gas and it's affecting the environment. Similarly, as I said, many of the petrol stations have buried tanks, and the volatile organic compounds are leaking into the soil and the soil is getting contaminated. The other airborne gaseous or airborne route is the route of dust, air erosion and air transport. So from various sites, including ash ponds, including tailings ponds, including mine overburdens, including municipal solid waste, fine particles of dust are carried by the wind and deposited in the nearby areas. So if you are living nearby one of these, occasionally in the dry months, you will find कि आपकी building का color change हो रहा है. Because why? Because the ash from the ash pond or the dust is coming and depositing over your building. God is kind, monsoons will come and it will wash away the building. But imagine there was a news item in Himachal that these fine dust particles were beginning to affect the pollination of the apple orchards. So to a building which are non-biotic and not alive, it doesn't matter if a dust particle comes and you wash it away. But if it starts to sit on the leaves and the flowers of the plants, then you have an issue there, even if it's a very thin layer. The surface water route, best demonstrated. Many cities have lakes. And the lakes are also their drinking water resource. So, God forbid, if you have not located your dumping site properly, whatever, industrial waste or municipal waste and you have something here or something underground, I don't know, solid or liquid. The tendency is that the ground is sloping towards the lake, and will you get surface contamination, or will you get groundwater contamination here? What kind of contamination do you suspect? I think I've gone outside the limit, but nevertheless. If this is clay, if the soil is clay, what will happen? When the rain comes, will the water go into the soil or will it travel along the slope of the ground? Right. So if it is clay, then So surface runoff on impervious soils, on sloping ground, next to a lake. It's a reality in this country. Several lakes are polluted because the dump is close to the lake. If you are on a pervious soil, then the situation changes. Then the situation is the water tends to go down, or it can be a combination of both. So if you are very far away, at IIT, how far away are we from a water source? How far is IIT from a water body? Do we have a lake nearby? No. The nearest freshwater body is the river Yamuna. How many kilometers? It's closer to CRRI than it is to IIT Delhi. So 10 kilometers away. So in such a situation, that's a totally different situation. What is likely to happen? What kind of soil are we sitting on in Delhi? It's alluvial, sandy silt, silty sand. It's not pure silt. We call it Delhi silt sometimes, erroneously. But if you were to give it an engineering classification, it is silty sand, sandy silt. So is it a permeable soil or an impervious soil? So the answer is right there, staring at you in the face, that if you are sitting on pervious soil and if the groundwater is not deep below, then your root is, and God forbid if you have a tube well or a pump here which extracts the water, then you are going to receive it. So two similar dumps but in different situations. So let's look at the pathways once again with this context. You can have the surface water route. The leachate and the leaking liquids can travel along the ground surface. Hopefully before they reach, if the source is very far away, it will evaporate. Because you do have evaporation all the time. Or you can have the groundwater route, or it can be both. So either way, here also the ground is going to be sloping towards, so the groundwater table is going towards the river Yamuna. You can also have a physical erosion route, so a gaseous route, a liquid route, and a physical erosion route. That means, the first question is, if I put any waste on the ground, solid waste on the ground in the form of a powder, will it go into the soil on its own? Well, I put talcum powder on gravel, on bouldery deposit. Let's do the extremes first. What is the size of boulders? 30 centimeters, let's say, bouldery deposit. Now I go and say I'll store talcum powder on top of it. What will happen? The talcum powder will go into the voids of the, physically it will travel. So for fines not to physically travel into the soil, the filter criteria between the waste and the soil must be met. Otherwise, some of the fines will go physically with the water into the void space of the soil below. Not very far. May travel maybe 30 centimeters, half a meter. If there's a very large difference, if the soil is clay and your waste is coarser, nothing will go from one into the other. But physical erosion route, the fines of the waste can travel with water and reach from one point to another. How far can they travel? If you look at the failures of some tailings dams and ash ponds, they can travel a kilometer or 2 kilometers. That doesn't seem possible. But in a dam, there's water and there is powder or soil or tailings. And when the breach in the embankment takes place, then this slurry travels like viscous fluid. And in some cases has traveled as much as a kilometer or 2 from the location of the breach. So there are physical pathways as well. So gaseous routes, airborne routes, surface water route, groundwater route, and physical erosion pathways. Who receives? Why are we so bothered? Well, they are going, let them go. Well, receptors, who are the receptors of the contamination? The biggest problem is if there's habitation nearby. If human beings are using this, then the nearby habitat and the ecosystems. So to the humans, the contaminant can reach them through drinking water. So our water supply comes from the rivers and the lakes, so that's surface water, or many cities rely on groundwater extraction. If you are doing swimming and boating and having recreational activities in your lake, then you can be affected because if the pollutants are traveling. And humans can also be affected by the air intake. If we are living close to a waste dump and there are airborne particles, this entire issue about smoke and smog in the winters when the Bhalaswa landfill got fire this time is an issue of air pollution. So animals can be affected. If we are using water for irrigation purposes, then crops will uptake whatever contaminants are coming, the roots can uptake it and it can come into the food chain. Industry uses the surface water and groundwater, so if there are some contaminants, it can affect the quality of the water being used by the industry. So everybody here is a receptor. If there is sensitive environment, they can be affected. So these are the ways in which we can be affected. And let me see. I'll come back, but I'd like to say the following. What about the impact? Simply stated, the larger the source, the bigger the problem. The shorter the pathway, the more quickly it can reach you, and the more the receptors. This photograph, for example, shows you that there is a waste dump here. It's a Google Earth shot, and there are people living all around it. These are houses, some sheds, some houses, some residential area. So obviously, if anything is coming out from this, it's going to impact this area. A simple thing like bad odor, it can be affecting everybody around this area. So let me try and articulate this a little better. So if I'm saying larger the source, then let us see there are 4 situations. All the waste dumps are of same size. The first statement is that if the waste dump is larger, obviously the impact will be larger because you have more surface area from which the bad odor can spread, more surface area on which rainwater can fall and therefore make more leachate. But suppose I have the same waste dump with the same quantity. Let us say the waste dump is 1000 units. However, its display, the way it is being placed is different. So purely from leachate point of view, which source is going to have a greater impact? Yeah, the one which is spread more, because the rainfall will be, let us say, 100 mm. It will have to be multiplied by the surface area over which the water is falling. Now, if the same waste dump is coming down in height but is being spread more, then the area over which it is spread is more, and quite clearly the leachate which will be formed by this dump will have greater impact. I have 2 waste dumps of the same size, same shape. Which source is going to give me more trouble? Well, the question is this in Rajasthan or is it in Bombay? If it's in Rajasthan, the total water which is going to fall on it is very less, because Rajasthan is an arid area. It doesn't get a lot of rain. If it's in Bombay, it's going to get more rain. So the same waste dump in a different location will get different impacts. So the same, so quantity is not the issue. The quantity, the surface area, the amount of rain. So if in Rajasthan you are having this much rain, in Bombay you'll have, so this will produce more leachate. And finally, a waste dump which is partly covered, suppose the waste dump is still operational, but it is partly covered with an impervious cover. Quantity of waste is the same, but I have an impervious cover. So obviously, a waste dump which has been partly covered with soil will have lesser impact than a waste dump which is not covered at all. So this is the way in which the size of the source impacts the environment. What about the pathway? Same waste dump in 4 locations, and I'm only looking at groundwater contamination now. As I said, if I have clay, impervious. If I have sand, here, but here to the ground. So clay and sand, same size, the source is the same, but the pathway is different. 2 locations. In one case, the groundwater extraction tube well is here, and in another location it is. So the source is further away from this well. So the pathway is longer. So this pathway is longer, this pathway is shorter. If my waste dump is in rock, how will I treat it? Is it impervious or pervious? For quite some time, we know that rocks are impervious or they are pervious. Yeah, so the issue is always about fractures. If they have fractures, joints, fissures, are they pervious or impervious? Are they more pervious than clay? Yes. Are they more pervious than sand? Depends on the size of the fractures, but some of them can have very large sized fractures. If you have rock on the surface, it can also be inclined. Hill slope, gentle slope. So the moment you have an inclined slope, your hydraulic gradient is up. So instead of the ground being like this, you have, let us say, a ground like this. And let's say this is your waste dump. Same quantity, but now the rock is got fissures, cracks. And what happens? Rain falls, it gets into these cracks and then travels along these cracks. So competent rock is impervious, but we rarely have competent rock on the ground surface. We have fractured rock on the ground surface. So many a times you will find that shorter pathway, not because the distance is less, if the well, but because the permeability is higher. And finally, we talked about source, we talked about pathway, let's talk about receptors. same same size of the dump, same soil conditions underneath. This dump is sitting on barren land. This dump in the middle of agricultural fields. This dump toward outskirts of a city. And this dump has sitting on all sides. Same dump, same size, same subsoil, same rain, but look at the receptors. Maximum receptors here. Larger the source, shorter the pathway, more the receptors, greater the impact. And whether it's a dump or a pond, it holds. So, if you look at it historically, waste dumps or waste ponds were first kept outside the cities, far away, 2 to 3 kilometers. The cities continued to grow because population doesn't stop. They grow vertically and they grow horizontally. And then the cities reached the dumps. And then they went around the dumps. And the dumps became part of the city. And for that I go back to the slide which I was showing you. If I look at this slide, here is the statement, larger the source, shorter the pathway, more the receptors, greater the impact. If I look at the slide, you see the landfill here and the houses all around it. And with these situations, it's there in Delhi, it's there in Bombay, it's there in all the major cities of the country. And these have a great potential. And now the Deonar landfill fire in winters caused shutdown of schools for several days. The smog in Delhi a month ago was attributed to the landfill fire at Bhalaswa landfill. These are beginning to impact the way we live. And there was a court judgment that all landfill fires should be put out. But these fires are not like fires on the surface. You can bring a fire tender and the dump is 20 meters deep. You extinguish the fire on the surface and the fire continues to smolder inside and it requires special action. So we will stop here today. We've seen the sources of contamination and their impacts, and we will continue the discussion later. But I'm open to any queries or questions that you might have or anything that is bothering you. Any issue, any problem which you have felt in your city relating to dumps or even ponds or any contamination issues? Okay, then in the next class we will take up the interaction of the waste with the soil to assess how contaminants from waste travel through the soil in the subsurface environment. Thank you. Have a good day.